Hey guys, we've got a new product for you today. This is a NAS box from Zettlab. This is their D4 from their series, so it's referring to a 4-bay NAS. It's quite an interesting product and they have thrown in some AI features into it as well, so we'll check those out a bit later on. Let's open up and see what we've got inside the box. They even included little handles to take it out, which is, attention to detail is really cool. It's very Apple-esque design for the box. So you actually have a little opening. They've definitely invested a bit of effort into making it convenient for users, but more handles for the NAS itself, because it's chunky. It's quite heavy. So the box itself was around 7.5 kilos. All right, this is the unit. We have some accessories in this box here, and that's it. The box itself, if you look at it, actually has almost an inch of kind of cover on each side to protect it for any bumps and drops, which is very nice. Inside here we have a back dustproof cover. It's a metal cover, and we have accessories themselves. We have the quick start guide, the power supply and power, as well as Ethernet cable. Very simple, all you need for a NAS box, you need the power to plug it in and network to obviously network it up, since it is a NAS after all. Let's talk about the box itself. So this is a 4-bay unit, and we have the base on the front here and some I/O, and we have a bunch of I/O at the back as well as the fans. So this cover just goes on the back and it just has magnets there, so you just go and it just through, so you can just mount it. It mounts like this. It will impede your airflow, so it doesn't really have to have it in there, but you get the option. So from the front, there is a little LED screen here, and we'll turn it on a bit later on. We have SD card reader, so it's a 4.0, it's one of the latest generations. We have a TF reader as well. This is basically the micro SD. You got USB-C, USB-A, and a little macro switch for copy on the front. So I guess in the settings later on, we'll find a way to be plugging an SD card and press copy, and it will save it to the Redone folder. I want to check that a bit later on. Then we have the 4 bays. So let me just open them up. So you literally go click on them. I like that they're labeled press, and they've got A, B, C, and D. And on the screen later on, we'll also see that they have references to the drives for your statuses. For the enclosure itself, you got the hard drive enclosure. So if you just press, you can open it up, put the hard drive in, lock it down. Very convenient, completely toolless, which is what you would expect for a home use. Really appreciate that. But at the same time, if you really wanted to, you can actually install SSDs in here as well. So you still have some screws in here, should you need to. And then once you've installed the drive, just slot it in. We'll load this up with drives a bit later on. Now let's have a look on the back. We've got the aforementioned 2 fans. So these look like they're around 80mm fans. Then we have some network ports. We've got a gigabit port, a 2.5 gigabit port. We have 2 USB-A's, 2.0. So these are not going to be for high speed, but more like if you want to connect other devices to this unit. We've got HDMI out as well as DC power, so this is for the power plug. We have a reset button as well as a power button on the back, and just a normal clicky button. That's kind of it from the outside. Then on the bottom, we should be able to remove this plate, and there should be an SSD slot over here. So in this example, it actually comes with a drive installed. So it's a PCIe Gen 3 x 4 drive over here, and it is a no-name. Well, at least I don't know this particular brand of SSD. I'm not sure if all of these units come with SSDs, but generally speaking, this is the only thing that you can replace in this unit is this SSD, and always install the hard drives. Other than that, this unit has a kind of a lockdown specs, and I'll cover that in a second. The actual SSD has a bit of a really thick thermal pad to the back plate, which is metal, so to spread the heat. I do appreciate that they haven't put some sort of weird feet or something you need to rip off to open up the bottom plate. As far as this unit is concerned, it can support up to 100 terabytes of storage. It can support up to 4 drives at 24 terabytes each, which brings it to 96 terabytes. And then it can support up to 4 terabyte SSD at the bottom here, which brings it to a full 100 terabytes. You can't limit it in terms of the specs. This particular unit is one of 4 that they sell. We have the D4 and D6, which are very, very similar. In fact, almost everything about them is the same. So they both come with an ARM-based ROC chip, which is an RK3588. It's an SoC, and it has up to 6 TOPS of NPU power, hence AI built in. So we'll cover that a bit later on. They both come with 16 gigabytes of LPDDR4X memory. So it's soldered on, you can't really upgrade it. And you got 32 gigabytes of eMMC memory, which is the OS drive for this unit. Since it's an ARM-based CPU, it's actually a custom OS that Zettlab provides. And you can't just go ahead and like delete that and install a true NAS or something like that, because those don't support ARM. In the future, maybe they will and you'll be able just to upgrade it, but at the moment you can't lock it down to the OS they provide with this. But it's supposed to be user-friendly and we'll check it out. The only difference between this unit and the D6 is, well, there's 2 differences. Is an additional 2 slots for storage, and there's an additional SD card slot, the full-size SD card slot, which is Gen 3. So you have 2 slots rather than just 1. Other than that, everything else is exactly the same. Then they also sell D6 and a D8, and those are actually upgraded. They're actually Intel Core Ultra 5 125H CPUs. So they're like last gen mobile units, which are actually kind of surprising. NAS boxes are generally like 4 or 5 generation old CPUs. This is quite cool. They're actually gone quite high end on those. Both of those units start with 32 gigabytes of DDR5 memory, and they can actually be expanded up to 96 gigabytes each, which is quite impressive. They also have 2 M.2 drives, 4x4, as well as a PCIe Gen 4x8 expansion card. So you can install a card or some sort of SAS expander or whatnot. But enough about those, let's check out this particular unit. In terms of the drives you can install here, they actually provide a list of compatible drives, but generally speaking, any SATA drive should be compatible. Unfortunately, it only uses SATA controller. You can't install a SAS drive, which is a bit disappointing because there's a lot of second-hand good SAS drives you can buy on eBay. But in this example, you have to go with SATA drives. So be mindful of that in case you want to go enterprise. This is really designed for home. So let's just plug it in and see if it boots up and how noisy it's going to be. It doesn't have a default boot, so you have to actually press the button to turn it on. It's lit up. Well, I saw the fan span for a second and then that's it. So actually, if it's cool, it turns off its fans. That's kind of cool. So you see a little screen here. Just take off the little screen protector. That's actually a nice looking unit. It's something like this you could probably install on your desk where you work. And ultimately, let's say an example that we have. When we record our footage, we take the SD card and put it into a little SD card converter and then upload it to our NAS. You could literally just plug it directly here, copy it straight to the unit and just save it down. That's really convenient. I'm going to install some drives into it. I'm going to kind of configure the baseline of it, test it out and see what kind of performance we get, what kind of AI features we can play with, and how convenient it is actually to use. So let's get to it. After loading it with drives, moving real data across it, testing with different network setups, and living with the Zettlab D4 on my desk, the big headline is simple. The hardware feels ready, the software is ambitious, and what really matters now is how it behaves in real workflows under sustained use. It doesn't yet have the years of polish and edge case hardening you get from a mature NAS operating system, but what genuinely surprised me is how substantial the updates already feel. There are real quality of life improvements like network bridging and terminal access for Docker containers that change how you use the system on a day-to-day basis. At the same time, you still get the sense that this is an evolving platform. So depending on your mindset, that will either feel exciting and forward-looking or slightly risky if you prefer something fully mature and deeply established. On the security and default side,
there are some decisions that I genuinely respect and I think deserve recognition. The remote access is turned off by default, which is absolutely the correct choice for storage devices that contain your sensitive information. You also do not need to create an email account just to get started, which feels refreshing in a world where almost everything forces you with a cloud registration before you can access your own hardware. When wiping a drive, the system asks you for a password confirmation, which adds a layer of safety against accidental destructive actions and shows attention to responsible design. However, password length is capped at 24 characters, which feels unnecessary, and there is no automatic logout after inactivity enabled by default, which I would like to see improved in the future. One of the strongest areas of the experience is actually the storage pool creation process. Instead of assuming you already understand RAID, the system actively explains what each configuration means in practical terms. When creating a pool, it shows capacity impact, performance expectations, redundancy level, utilization rate, and clearly lists advantages and disadvantages in a way that makes the decision process less intimidating. For my own setup, I chose RAID 5, which made the most sense. It gives protection against one failed drive while still keeping a healthy amount of usable storage. Also, it's worth noting that initial drive syncing with large capacity disks can take days rather than hours, which is normal for parity arrays, but something users may not expect at the beginning. In the real-world performance testing on the 1GB Ethernet, the large 15GB file transfers were consistently around 100 to 110 megabytes per second from the PC to the NAS, and roughly 100 to 115 megabytes per second in the reverse direction. That essentially saturates the 1GB connection, which is exactly what you hope to see from a properly functioning system in this class. When testing rsync from another server, speeds varied more depending on the file structure, with receive speeds between 50 and 70 megabytes per second and write speeds somewhere landing in between 30 and 50 megabytes per second. That variability is typical when handling many small files versus large continuous data streams, and it well reflects the real-world usage rather than ideal benchmark scenarios. Moving up to the 2.5 gigabit connection did improve large file transfers, but it is important to frame this realistically rather than exaggerate expectations. Small file performance remains similar to 1 gigabit, which is normal because the system overhead and protocol handling becomes the limiting factors in the cases like this. The large 15GB transfer improved to around 130 to 140 megabytes per second from the PC to the NAS, and around 140 to 150 megabytes per second from the NAS back to the PC. So while there is a measurable gain, it does not fully saturate the 2.5 gigabit bandwidth, meaning you benefit from the upgrade, but you do not reach the theoretical maximum throughput. Network bridging is one of the more interesting features here, but it's also one of the easiest ones to misread on paper. It doesn't stack bandwidth or combine ports to give extra throughput. Instead, it splits the traffic lanes, so your direct PC to NAS transfers don't fight with the regular LAN traffic. This means you can connect 2.5 gigabit port directly to your PC for heavy transfers while maintaining a separate connection to your network for other users or services. In practical terms, this creates a more stable and predictable performance during a large data moves, which is generally useful for creators or anyone moving large media files regularly. The app ecosystem is where the platform starts to reveal its flexibility. Official Docker and virtual machine support dramatically expands what you can do with this machine. You can also choose whether the application is installed on a fast SSD or on the protected storage pool, giving you control over balancing performance and redundancy. Terminal access for Docker containers is now also available, which immediately gives the system a level of flexibility that feels much closer to a proper home lab setup rather than a typical locked down consumer NAS. At the same time, there is still no SSH access to the underlying OS, which places the system in an interesting middle ground between fully open server and a guided NAS appliance. The AI-powered photo management and media indexing features are promising but require realistic expectations regarding processing times. You can schedule AI learning so it does not interfere with active tasks, which is a thoughtful addition for maintaining responsiveness during heavy use. If you import a massive archive of media files, the learning process is gradual and does not produce instant results, particularly on large datasets. For users starting fresh with the smaller libraries, it will feel more immediate, but on the larger system, this clearly is a background process that takes patience. For my setup, it is still chewing through the library, so I haven't actually been able to use the AI features and test them out yet. Over the extended use, the front display proved more practical than initially expected. mainly because it allows quick visibility into capacity, CPU load, memory usage and drive health without needing to open up the web interface. It is still a very simple screen with basically just showing on-off control and no real customization, but for quick status checks and peace of mind it does the job well. The LED strip gives you a handful of effects, but right now it feels more like a decoration than a tool. You can't adjust brightness and it isn't tied into the system in any meaningful way. The frustrating part is that potential is obvious. With deeper software hooks, this could become a genuinely useful status light for things like backups, drive warnings, sync activity or error alerts. Acoustically, the system behaves predictably, with silent mode being desk-friendly, smart mode providing a balanced profile, and full speed producing a loud, low-frequency hum. The noise at full speed is not high-pitched or irritating, but it's loud enough that I wouldn't want it to be running constantly beside me during the workday. Drive noise is heavily dependent on the disks you install, and in my case, enterprise drives were clearly audible during active workloads. Idle operation remains quiet, but under load, the acoustic experience is defined as much by drive choice as by the chassis itself. The front import functionality is another practical feature that emphasizes convenience over chasing theoretical maximum speeds. Plugging in media and copying directly is straightforward, with transfer speeds between 70 and 75 megabytes per second during my testing. While that may not fully saturate every possible interface capability, the workflow is smooth, clearly presented and reassuring thanks to the visible progress indicators and transfer history logs. Additional options like file filtering, cloud upload and manual import configuration made it flexible without being complicated. After a few weeks, this doesn't feel like a typical plug-and-play NAS, but it's not a full DIY server either. It sits somewhere in the middle, with solid hardware and software that is improving fast. On 1 gigabit speed, it's steady. At 2.5 gigabits, it's quicker for big files, and features like bridging plus Docker make it way more flexible than I expected. If you're okay with a platform that's still growing, it's pretty compelling. For me, the most surprising part was not the raw transfer speed, but the overall usability and the visible trajectory of development. The system is not perfect, but it demonstrates thoughtful design choices and willingness to iterate based on the real-world use. If update momentum continues and maturity increases over time, this could become a very compelling hybrid between appliance simplicity and home lab flexibility. The real question is not whether it works, but whether it fits your specific workflow and expectations for a storage platform. If you think this NAS might be what you need, check out the link below for more detail. Thanks for watching, and we'll see you in the next one.